Backside of the 2.1 notes, we're taking a look now, and considering the parent function, we know we've talked about in the first video the word parent function, the phrase parent function, the starting location for us in this situation, absolute value function. We'll see a lot of parent functions as we go through the class. And now we're going to compare that to this standard form, the general form of an absolute value function, which has a bunch of different letters in it that we haven't seen before, and we'll talk about them a lot in this particular video. I do want to make a comparison, though, and write the parent function in standard form. So if I were to do that, we need to understand that we have a 1 as a coefficient in front of the absolute value. So taking the place of the a would be the number 1. And actually I have to backtrack here. 0 is h in this situation, and k would be 0 also. So if I were to write out the parent function in standard form, those would be the numbers. A is 1, h is 0, and k is 0. Now, we'll move forward in this eventually and take a look, and the 0 and the 0 for the h and the k will make sense to you. But let's go ahead and focus on what does each of those letters mean, and what does it tell us about an eventual picture that we'll have. The first thing I want to check out is the letter A. And in this situation, we know that the letter A is that coefficient in front of the absolute value function. Very simply put, there's a couple things that A tells us. If our A value is a positive number, then we know that our absolute value is going to open up. Now that looks kind of sort of like the letter V for all of us, which we mentioned in the first video. Kind of nice that V value, it looks like the letter V. If our A value is negative, then our absolute value is going to open down. And the V would be flipped, reflected, if you will, from geometry class, and the V is pointing downwards. How far is our A from 0? Now, this is one of the trickier concepts for us, but this is a conversation about width. All right, so if I go back just real quickly and take a look at our parent function, that parent function to us, we can see a little bit of spacing between the two, again, geometry speaking, rays in the picture. Excuse me. So let's go ahead and understand that if our width, if our A value is a distance that is equal to 1. That could be 1. It could be negative 1. We know how absolute values work back in middle school. And we know distance is a conversation, or absolute value is a conversation about distance. We're going to have the same width as the parent function. When we say PF, we're going to say parent function. We know that the distance, if the distance gets larger than the number 1. And again, that's both a positive or a negative number. We're actually going to have a graph that is skinnier or thinner than the parent function. And then finally, if our A value, if that distance is somewhere between 0 and 1, we're actually going to have a wider function. So conceptually, that might not necessarily make too much sense in terms of how that appears until we get these graphs going. But for now, let's just go ahead and understand that the a value does two things. It could keep the absolute value function pointing upwards or make it go downwards if it's negative. And then we also have to take a look at the distance. And again, we know distance is always a positive conversation. But is the distance equal to 1, greater than 1, or is the distance somewhere between 0 and 1? That's what we're looking at, the a value. It will tell us a lot of stories when we do our